This section takes us into the Model View Controller pattern, sometimes called MVC for short. The Model View Controller pattern helps us organize software between an external interface and our internal response to that interface. It is a way of being able to manage our coupling cohesion that we talked about a while ago now, so that we can decouple the features that are critical towards the user's needs, the thing they want. They want to do banking, they want to play a game, versus the mechanics that's required to manage that interface, whether it's a mobile app or a website or just basically a desktop application. So the MVC pattern establishes a strategy for how we connect user displays to business logic and makes that as reusable and flexible as possible. And so it also gives us a way to be able to manage non-functional requirements, like the latency. If you click on something and have to wait for it to respond, or if there's a bunch of users hitting something at the same time, this lets us be able to manage that a little bit better. So to talk about that, we're going to start with an analogy. And it's actually a fairly apt analogy because remember, patterns are ways of solving problems. They don't have to be exactly code all the time. So in the diner, Don's diner specifically, Don has a very specific way of naming things and who he hires. So he has Wally, Wanda, who are the waitstaff, Charlie and Chelsea, who are the chefs, and Carrie, the cashier. So Don's really into alliteration. And everybody knows Don's Diner. Everybody loves Don's Diner. It's the favorite in town, and everybody knows the routine. So when you walk into Don's Diner, you meet up with Wally or Wanda, and they can give them their order. They walk it back to Charlie or Chelsea, who cooks your food, hands it back to Wally or Wanda, who's going to bring it up to you. You enjoy your meal, you have a nice conversation, then you give them your payment. So Wally and Wanda will wander over to Carrie the cashier, who rings you up, writes a wonderful note, and returns that receipt and your change through Wally and Wanda. Very standard, something we're very all familiar with, and we just kind of follow the habit all along. But the problem is Don's Diner is super popular now. With the tight job market, there's not as much wait staff, and he has a hard time hiring. So the orders are going up, but he can't really keep the crowd flowing through as well. There's a lot of wasted time as things are running around and do that. So specifically, Charlie and Chelsea are constantly busy, and so Wally and Wanda are kind of stuck waiting for them to give them the order. And then when they do finish something, Wally and Wanda are doing what they do best, talking with the customers, picking up their plates, doing their orders, and they have to wait for them to flag them down and signal them to come get the food. So fortunately, Don's wife is a object-oriented software consultant. And she says, you know what, I know how to fix this. We add a computer, because that's what we always say. And so we add the computer, but more importantly, we apply the model view controller pattern to solving the problem. So let's look at how we can take that problem, that space, that messy interaction, and clean it up using the MVC pattern. So the issue, again, is this bottleneck. People waiting, people interacting. These two are too coupled. There's too much interaction between these two that's going on, and they can't get their normal work done, and they can't separate the other tasks they need to do because they're too busy working with each other. And so MVC helps us solve that problem by introducing a third party. So the customer comes and gets the order, but now we're going to introduce that computer. That computer is going to be a place that's going to store that order. So now immediately when the customer asks for something, Wally and Wanda can say, hey, here's your order going on. And then that gets put in front of a screen for Charlie and Chelsea to pick up however they have it going on. And better yet, it organizes the data that's coming in. It manipulates that data, changes the data. So maybe I have 5 orders that all have French fries. Well, they can get an interface, say, hey, drop a super big order of French fries down in the fryer. And so when the food's ready, now they ring a bell or flag something on the computer or some other way. Instead of waiting to flag them down and having to interact with them, they just simply say, my task is done. I have changed something. You go and respond to that, which then is the flag for the wait staff to come and get the food. This actually probably should be familiar because this is the way most of the restaurants tend to work. They might use a little flag of piece of paper to do this interaction, but now in the computer age, many do use the computer, and that's good for us because they want to hire us to do this software. And so the delivery of the food happens through the user interface with minimal interruption to our wait staff. That is the purpose of the model view, and controller. So the model is the thing that's most important. People come to Don's Diner to eat the food. Now, they love the wait staff, don't get me wrong. They love the interface, but without that core business model of great food, nobody really is going to be coming to visit. But that also has the great benefit that the waitstaff can focus on the things that they do best. I can now separate those duties, and that waitstaff can be the best waitstaff they can be. They can ask, "How's the kids?" They can check on, is the food good, and just do more stuff with the user interface to interact with the customers. And the controller helps to mediate all that. It has some intelligence, and it helps centralize that process of how the model receives information from the interface and then to some degree feeds it back as well. So you've read about this in your readings this week. This picture comes from an older document. Sun Microsystem, which was bought by Oracle, used to own Java, and their Enterprise Edition used to talk about this. And it's interesting because this is an older view which gives us this idea of the signal, the event, that pop-up that goes in. Now, reality is many software platforms on the web or otherwise didn't use this as part of it. So the pattern still applies, but for a long time, particularly in the pre-JavaScript Ajax days, web pages they had to refresh and go get information. But particularly in high critical apps, it's perfectly reasonable to send out a signal to say, "Hey, go and refresh this." So if you're a trader or if you're playing a video game, you're going to get signals to say, "Hey, something changed in your environment," and your user interface will go get that. But this separation of controls really identifies what the model does. It does the state of the application. It does the updates the data. It handles all that backend intelligence. The view renders the model and it lets the user do actions, and then the controller responds to those actions and then updates the model according to the rules of that interface. So the side benefit that we talked about in Don's Diner is the analogy, improving the cohesion and the flow of our wait staff and our chefs and of our cashier. But the other advantage of this is the reusability. So Don's kind of trying to get hip. He wants to add in some LCD panels, which is going to let people surf the web, watch videos, and then order and stuff at the booth. That way, even in my interaction with the waitstaff, they still come around, they still are available, but they can be more of his concierge and friends than having to just simply take the order. So the customers come in, they put their order on the screen, it goes back to the computer puts it in front of the waitstaff, the chefs, Charlie and Chelsea. They signal when the food's ready, and then the customer is told, and they can always go pick up their food on their own. So for takeout orders, for people who are in a hurry, for the people who don't know Wally and Wanda as well, and as Wally and Wanda get a little older, they're not going to be as fast. They might retire. This keeps everything moving in another format. Now, the politics of computers replacing people aside, this works well in a computer environment for reuse. We can have our cook staff receive orders in any number of ways. Now, if Uber Eats wants to make orders, they can do that online directly. I don't even have to have a person picking up the phone and taking orders like that. It really streamlines the flow of this. It makes our business busier on the thing that cost us the most money to build, the core business, and then we don't have to spend money on things that don't necessarily add value. In software, that has a little bit of different connotation because it allows us to have our core software have many different interfaces, many different presentations. So I can now use the same core software in a mobile app, a web service, or even any sort of desktop application, and be able to swap it out as needed. So the trick to this is putting in the action. Don's Diner's analogy, it has smart agents out there that can help solve this. It's up to you to see the flow and the interaction and to manage it. And as we talked about many times before, it's not about understanding it, it's about building the habits. And so you need to be able to see the model view controller when it shows up in code and see how it can improve your code and make it a habit of mind to build it that way. And that's going to be the next activity we're going to work through. You're going to get started here before you come to class. And then when you come to class, we're going to work through the details of looking at code that's not set up well, and then code that is set up well through the model view controller pattern.